reviews for Math 1314 and for Math 1324, which are presented by Ms. Yvette Chuca, Ruben Carizales, and Albert Isasi. Our session will be starting soon. This session will be recorded so that you can come back to it later if you need, and so others who missed today's event will be able to come back and watch it. And so now at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with information we will be sharing. Ms. Patricia will be sending individual messages to everyone to gather your student ID numbers so that you can so that she can sign you in. Also, if you're here for the Math 1324, please follow the link that will be posted on the chat. And without further ado, I will pass it on to our presenters so that they may begin.
Hello, everyone. Welcome to Friday Happy Math Hour. So today for 1314, we are going to, the schedule says we're going to talk about matrices, but I wanted to first look at some examples for section 7.5 since that is still what's going on this week. And then we'll go into a little bit of matrices. And so at any time, if you have any questions, please let me know and we will address your question. And if you are here for 1324, they just posted the link as well. So in chapter 7, we're looking at linear systems of equations, but now for 7.5, we'll be looking at inequalities. So an inequality basically is an equation that instead of having an equal sign, might have a less than sign, a greater than sign, a greater than or equal sign, or a less than or equal sign. So that is how we know that it's an inequality. An ordered pair is a solution, an ordered pair AB is a solution of that inequality if when you plug in the A and the B for X and Y, you end up with a true statement. And we'll look at that, what I mean by that in the next examples. Okay, so a graph of a system of inequalities might look like this. And so if you notice in this graph that I'm pointing at, this is the equation or the inequality for this line. But if you notice, it has a dotted line. And we're going to be using a dotted line if the inequality is less than or greater than. If you look at the second equation, which is in blue here, notice that the inequality is a greater than or equal to sign. And so for those inequalities, we're going to use a solid line. And so everything that you see that is shaded are solutions to either one of the inequalities or to both inequalities. And again, with the examples in a few minutes, we'll be able to, our goal will be to graph these inequalities and find the solutions. Okay, so when we want to find the solution to a system of inequalities, first we need to be able to graph an inequality. And so to graph an inequality, what we're going to do is we're going to change the inequality signs to an equal sign. And then we're going to decide if we're going to use a dotted line or a solid line. Once we graph that line, then we're going to choose what we call a test point. And you can choose a test point in each of the regions. And if it satisfies the inequality, then you shade where that point is. Okay, so again, in our examples, you'll be able to see it a little bit more clear. So for this example, it says sketch the graph of x plus y greater than 5. So the first thing we're going to do is we're going to replace this inequality sign with an equal sign. Then our next job is to graph this inequality, or this is to graph this equation, and we can use any method. So if you prefer to use the slope-intercept form, then you can do that. Or in this case, I'm going to use the x-intercept and the y-intercept. Okay, so recall that for the x-intercept, we let y equal 0, and we solve for x. So if y is 0, then my x is going to be equal to 5. So my x-intercept is 5, 0. And then for the y-intercept, remember we let x equals 0. So if x is 0 and I solve for y, then y is equal to 5. So my y-intercept is 0 and 5. So I can use these 2 points to graph this equation. And that graph is going to look, well, first let's decide if we're going to have a dotted line or a solid line. So if you notice, the inequality sign is a greater than sign. That means that we're going to use a dotted line. Sometimes instead of dotted line, they might call it a dash line. But either way, it will be a dotted or a dash line. So here's my intercepts, and then here's my line. Okay, and notice that it is dotted. And so now we're going to move on to the second step. So for the second step, we're going to choose what we call a test point. The test point that you choose cannot be on the line itself. And so the easiest test point, in my opinion, if it's available, would be 0, 0. And so I'm going to go ahead and choose that as my test point. So this is my test point here. And what we're going to do with this test point is we're going to write our inequality, which is x plus y is greater than 5. And so for x, my test point is 0. And for y, my test point is 0. So 0 plus 0 is 0. And 0 is greater than 5. So if you notice, this is a false statement because 0 is not greater than 5. So since we get a false statement, we're going to shade the opposite side of where that test point is. So if you notice here, the test point was located here. Since we got a false statement, we shade on the opposite side of where that point is located. And so here is the solution for this equation or inequality. And so what this means is that you can pick any point in the shaded green area, and if you plug it in for the inequality for x and y, it's going to result in a true statement. Okay, and if you pick any point on the other side, then it results in a false statement. Okay, so your answer would be this graph that is shaded in green. Let's try another example. Sketch the graph of x minus 2 squared plus y plus 1 squared less than or equal to 9. Since we want to sketch this, then if we look at the equation, then you might recognize that this is a circle. And so the first thing you want to do is replace your inequality sign with an equal sign. And then second, we're going to graph. Okay, so we have, you want to remember the standard form, which is x minus h squared plus y minus k squared is, this should be equal to r squared, where the center is h and k, and then your radius is r. So in our inequality, we have x minus 2 squared plus y plus 1 squared is less than or equal to 9. And so the center is going to be 2 and negative 1, and our radius is 3. So if we plot that and we graph it, and I should have removed that, but here we would have our circle. So we have our center, and then we're going to use the radius to go up 3, to the right 3, to the left 3, and then we go down 3. Now, since we're using an inequality sign, then what we want to do is use a line. Therefore, our line is going to be solid. Okay, and so here's a better picture of the circle. And so we still need to pick a test point. Okay, so our test point is going to be 0, 0. We can use 0, 0 because it's not part of the line. And so here, here's my test point. So if I go ahead and plug those points in, if x is 0 and y is 0, and we simplify, we get negative 2 squared, and then we have 1 squared. So negative 2 squared is 4. 1 squared is 1, so 4 plus 1 is 5. And 5 is less than or equal to 9. That's a true statement. So we're going to shade where that test point is located. So remember, our test point was here. So we're going to shade that, and then this would be my answer here. If we had gotten a false statement, then we would shade everything on the outside of the circle. Okay, so let's try another example here. Notice that this system of inequalities is made up of a line and a parabola. And so now we have two equations instead of having just one. The process is still the same. We're going to graph each of these and then see where they intersect or they have common solutions. So the first thing we want to do is graph this inequality, the first one. So I'm going to change the inequality sign to an equal sign. And I'm going to choose x-intercept and y-intercept. So for the x-intercept, if y is 0, then x is -1. And for the y-intercept, if x is 0, then y is equal to 1. So those are my 2 points. If I sketch them, then my graph will look like this. Notice that I'm using a solid line because my inequality sign is the less than or equal to symbol. Next, we're going to graph the, choose a test point. So the test point here that I'm going to choose is 0, 0. So again, if I can use 0, 0, I'm always going to use it because it makes everything so much easier. So 0, 0, I'm going to go ahead and replace that into our inequality. So if x is 0, y is 0, then I get 0 is less than or equal to 1. And that is a true statement. So that means that we're going to shade the same side where the test point is located. And so that graph will look like this here. Okay, so that was the first equation. Now we're going to do the same for the second equation. So for the second equation, we're going to replace our sign. I'm going to go ahead and use the x-intercept and y-intercept. And notice that it's also a parabola since the x is squared. So if y is 0 here, then we get x is equal to plus or minus 1. So my x-intercept is 1, 0, and -1 and 0. For the y-intercept, if x is 0, then y is going to be equal to, and these should be equal signs right here. I forgot to change them. But the y will be equal to -1. And so then if we plot those, we have our x-intercepts and our y-intercept. We're going to use a solid line since the inequality is less than or equal to. And so next we need to find a test point. Okay, so my test point, I can use 0, 0 again. So if I let x be 0, y is 0, then 0 is less than or equal to 1. That's also a true statement. And so I'm going to shade everything that is within the parabola. And so we've graphed both lines, but now we need to put it all together. Okay, so your first inequality was this one here. The second inequality was this one here. So what I like to do on paper is I like to graph the first one, and on the same coordinate plane, I will graph the second one. And I try to use different colors so that it's easier to see. Here I'm using the computer to help us visualize it. And so I try to use the different colors as well. But if I put it all in the same x coordinate plane, then here you're going to see that for the parabola, your solution is everything that is inside of this parabola. And then for the line is everything that is on the bottom. While we look at this part, the parabola and the linear inequality, then they both have what's the darker shaded area common to both. And so that's going to be the solution for both of those. Okay, so your solution here is going to be this area. If you're taking a test in class with paper and pencil, I usually tell my students to make sure that they identify their solution by either making it darker or making an arrow or drawing an arrow pointing to the solution. In WebAssign, they usually have, there's some where you graph, and then there's some where you pick a multiple choice. So you might get either one. All right, let's try another one. Sketch the graph of the solution set of the inequalities. And so here we just have two lines. So we do the same process. And I'm gonna just put everything on the same slide so that we can just see everything roll out. So the first step was x plus y, change the inequality to equal sign, graph the equation. So I'm choosing the x-intercept, y-intercept. So if y is 0, then x is 3. If x is 0, then y is 3. This is going to be a dotted line since I have a greater than symbol. And so this is the graph for that equation. Next, we want to choose a test point. I can use my favorite test point, 0, 0. So if I plug in 0 for x, 0 for y, then I get 0 is greater than 3. That's a false statement. So that means I'm going to shade on the opposite side of the line. And so this would be my result for that inequality. Now if we move to the second equation, then we have x plus y is equal to -1. I'm going to use the x-intercept, y-intercept. And so if y is 0, we get -1. If x is 0, we get y equals -1. So I plot my intercepts and I graph the line. It is going to be a dotted line since the inequality is a less than sign. And so this would be my line. Now I need to choose a test point. I'm going to use 0, 0 again. So if x is 0, y is 0. 0 is less than -1. And that is going to be false, right? Because 0 is greater than -1. So we're going to shade on the opposite side, which is down here. So this would be our result. Now if I put them together in the same plane, this was our first graph, second graph. Together it would look like this. And if you notice, there is no part where the graph is going to be, where they're going to have a common solution area. And so we say that there's no solution. And so I just wanted to give you just a little bit of examples from 7.5 before we jump into matrices. Okay, so we're going to go ahead and switch to the matrices. Is there any questions on these inequalities? And if not, then we'll switch to the matrices. And let me see. Okay, so we're going to start with 8.1. So for some of you, you might be in 8.1 already. For others, you will be starting 8.1 probably on Monday or Tuesday. And so for 8.1, we're going to be looking at what is a matrix. And so basically a matrix is a rectangular array of numbers. So we use brackets. And then inside of the matrix, you're going to see numbers that make up rows and columns. So the rows are going horizontally and the columns are going up and down. Okay. These numbers that are inside of this matrix, we call them elements. And so here you can see this matrix has column 1, column 2, column 3, and then it goes on to column n. And then you have row 1, row 2, and row 3. So again, this is your rows are horizontally and your columns are vertical. Now, one of the things that we're going to need to know is the dimension of the matrix, which just means how big is this matrix? So what is the size of the matrix? And so the size of the matrix or the dimension is determined by the number of rows and the number of columns. And we always write it as m by n, where m is the number of rows and n is the number of columns. So in this example, we have m rows, so we would say this is an m by n matrix because it has m rows and n columns. Now the other thing I want to highlight here is the entry can be found by whenever you see this just means what number is located in the ith row and j column. And we'll do some examples here in a second. Okay, so the size of the matrix, as I mentioned earlier, another word for that is the dimension. And we find that dimension by the rows and columns. So in this example here, we have one row, two rows, so that we would have the two here. And then we have two columns. And so we say that this is a 2 by 2 matrix. So if a matrix has the same number of rows and the same number of columns, that's considered a square matrix. Now this one here has only one row, but it has two columns. So we say this is a 1 by 2 matrix. If it only has one row, then we call it a row matrix. And then the third one is a column matrix because it's made up of only one column. And this column matrix, we can see that we have one row here, and then the second row, so that's a 2, and then one column, which is the 1. Now this last matrix has two rows and two columns, so it's a square matrix, but it also has a special name, which we call it the identity matrix. And the identity matrix is made up of ones in the diagonal, and everywhere else you're going to have zeros. Okay, so I have some examples here. I'm going to give you about 20 seconds, and what I want you to do is try to match these, and then I'll give you the answers so that we can see if you were able to identify how big the matrices are. So I'll give you about 20 seconds. You can try it. Okay, so let's see if you were able to match them correctly. So this first one, how many rows does it have? It has 1. How many columns does it have? It has 1. So if you guess the letter G, then that was the correct answer. Okay, the second one, you have one row, but then you have 1, 2, 3, 4 columns. So if you guess C, then that was the correct answer. Okay, and then the last one has one row, 2 rows, and 2 columns. So that's going to be a 2 by 2, which would be letter B. And this letter C is actually a special matrix as well. We call it the zero matrix because it's made up of all zeros. And then the last one here, we have 1, 2, 3 columns and 1, 2, 3 rows and 2 columns. So that's going to be a 3 by 2. And so that answer was letter D. And so this is the way that they were matched up. Okay, so that is determining the dimension of the matrix. The next thing we're going to do is finding out what the augmented matrix is. So the augmented matrix is basically, we're going to use all the coefficients of this linear system, and we're going to place them on the left side here. And then we're going to use the coefficients, which are the numbers without the variables, and we're going to use those as our constants, So we're going to use our constants, which are all the numbers without the variables, and we're going to place those on the right side. And so we use a vertical line to separate the coefficients and the constants. So here it says write the augmented matrix for the system of linear equations, and what is the dimension of the augmented matrix. And so here what we want to do is we're going to be able to write down what our variables are, and then on this side we're going to put our constants. And so for the first row we have x, the number in front of x is 1, so we would write a 1. And then the number in front of y is 3, so we would write 3. And then here we don't have a z, so we would write 0. And then w has a -1, so we would write -1. and then our constants is 9. And so if we write those out, then that's what we would have here. And then the second one, there's no x, so we use 0. Y is -1. Z is 4. W is 2. And then our constant is -2. And then the third one, we have x is 1. The coefficient of z, there's no y, so we put 0. The coefficient of z is -5. The coefficient of w is -6. And then we have 0. And then the last one, the coefficient of x is 2. Then we have 4, -3, 0, and 4. And so if we look at this augmented matrix, then we see that we have 1, 2, 3, 4 rows, and 1, 2, 3, 4, 5 columns. So that would be our dimension. Okay. So if I have a system of linear equations, it says write the system of linear equations represented by the augmented matrix. So now we want to go reverse. We have the matrix. What is the system? Okay. And so remember, this is one equation here in this first row. I only have 2 coefficients. So I'm going to have 2 variables. They don't specify what variable to use, so I'm going to use x and y. And so my system will look like 6x plus 5y is equal to 2. And then I have 3x minus 9y is equal to 0. And that would be your solution. Okay, so let's try another one. So here, the 1 is going to be the coefficient for x. And having a 0 here means that the coefficient for y is 0, which 0 times y is just going to be 0. So if I write this equation, then I get x is equal to 4 and y is equal to 3. So our goal in a little bit, when we move forward to some other examples, is for us to always have our augmented matrix written in this form, because then we can identify what x is and what y is. Okay, so we want to solve systems, and we're going to do that by using some methods. But before we go into that, we need to know what a row operation is. And so we have 3 row operations. The first one is that you can interchange any 2 rows. So for example, here, we're just switching row A with row B. The second operation is that we can multiply any row by a non-zero constant. So here I'm multiplying C times row A. And then the last one is we can add 2 rows together. So I can add this row plus this second row. So we're going to practice some of these. It says interchange the first and second rows of the original matrix. And so if you notice, they just want us to switch row 1 with row 2. So if we do that, then we end up with -1, 2, 0, and 3, 0, 1, 3, 4. And then the last row, we didn't do anything to it, so we just write it out. Okay, it says multiply the first row of the original matrix by 1/2. So this first row, we're going to multiply it by 1/2. So 1/2 times row 1. So 1/2 times 1. Let me go over here. So let me get my pencil. It'll be easier to look at it this way. Give me a second here. Okay, so what we're doing is we're taking 1/2 and we're going to multiply it times 2. So 1/2 times 2 gives us the 1 here. And then 1/2 times -4 gives us -2. 1/2 times 6 gives us 3. And 1/2 times -2 gives us -1. Now the other rows, we didn't do anything to them, so they stay the same. Okay, so that would be our answer. Now, symbolically, the operation that we did is represented as this here. we multiplied 1/2 times the first row, and then whatever answer we got, we put it back in that first row. Okay, so that's a symbol for that. And then the last one, add -2 times the first row of the original matrix to the third row. Okay, so in symbols, we're going to do -2 times row 1, and then we're going to add it to the third row, and then we're going to put our answer back into the third row. So whatever answer we get, we're going to put it into the third row. So when you're doing these, since we're not changing row 1 or 2, then we can just write them out as they are. And so now what we're going to do is, let me get my pen out again. Okay, so it says to multiply -2 times row 1. So -2 times row 1 is -2. And then it says to add it to the third row. So -2 times 1 is -2, plus the 2 is going to give us the 0. And then we have -2 times 2 is -4, plus 1 will give me -3. And then we go -2 times -4 is +8, plus 5 gives me 13. And then -2 times 3 is -6 plus -2, -8. And so that would be our row operation for that letter C. Okay, so what is the reason we want to use those row operations? So here it kind of just gives you the process of what we're trying to do. So first, you're going to be given a system, and the system looks like this. And notice in chapter 7, that's what we've been working with. And in chapter 7, you learn that you can solve a system by either using the substitution method or using the elimination method, or you can even graph them to find the solution. In chapter 8, you're also going to learn 3 more ways on how to solve those systems. Okay. So in chapter 8, what you want to do is you're going to take your system, and then the first thing you want to do is write the augmented matrix. Okay. So again, the augmented matrix is made up of coefficients and the constants. So this system becomes 6, 5, and 2. And then we have 3, -9, and 0. Then we're going to use row operations, the ones like we were using earlier, so that we can rewrite our system so that we can have ones in the diagonal and zeros everywhere else. If we can make this matrix look like this one, then from here we'll be able to get our solution. So here we would read it as x is equal to 6/23 and y is equal to 2/23, and then that would be our solution. Okay, if we can get it to look like this one, that is called reduced echelon form, and we can this whole process is called Gauss-Jordan elimination. Okay, so let's try some examples. It says use matrices to solve the system. So here's my system. So again, the first step is write your augmented matrix, but also you want to know what is your end goal. Your end goal is to make your system look like this, where you have ones in your diagonal, zeros everywhere else. And if you can make it look like this, then your solutions would be x equals a and y is equal to b. How are we going to get to this goal? We're going to use row operations. Okay, so here's our first step here. Let me write our goal in this place here so we can always remember what our goal is. So our goal is to get to this point, but first you want to take your system and write the augmented matrix, which is right here. 2, 4, 8 1, -1, and 5. I always recommend that you start with this first position and you want to make whatever is in here a 1. Okay. How do we make something a 1? Well, 1, you can see if the bottom one has a 1, and then we can switch rows. If you have let's say you have like the number 4, let me just write that out. Let's say you had a 4 and something like this. And you want to make this a 1, then you can multiply by 1/4 by the reciprocal, because 1/4 times 4 would be 1. Okay, that's if you had something like that. But going back to our problem, I need the 2 to be a 1. So my choices are I can multiply by half, or since I have a 1 below it, then I can switch my rows. And so the symbol for that is I'm going to switch row 1. The double arrow means to switch, and then I'm switching it with row 2. So I'm going to write this as 1, -1, 5, 2, 4, and 8. Okay, so that is my first step. Now I have a 1 in this location, and I have a 1 here. The next thing we want to do is go ahead and use that 1 to help you make anything below it a 0. And so here I have a 2. I need to make this 2 a 0. Okay, so what we can do is you want to multiply the 1 by the opposite of whatever you see below it. So the opposite of 2 is a -2. And so we're going to multiply this one by a -2, and then we can add it to the 2. So it's going to look something like this. And I have it on the next slide, but I want to go ahead and just do it here really quick. So I'm going to multiply -2 times 1 is -2. If I add a +2, then I get 0. Okay, and that's what we want. And so let's do that on the next slide. So we're going to take -2 times row 1. We're going to add it to row 2. And whatever answer we get, we're going to put it back in row 2. Okay, so row 1 is not going to be changed. So I can just write that row 1. 1, -1, and 5. That's my row 1. I do not want to change it. But now I'm going to go ahead and multiply -2 times 1 plus 2. That gives me 0. And then I keep going across the row. -2 times -1 is +2 plus the 4 gives me 6. And then I go across again. -2 times 5, -10 plus 8 gives me -2. Okay, so now if we compare, let's check where we're at with our goal. Okay, so we already did this. We have a 1 and a 0. The next step is let's make this diagonal a 1 as well. You could go and make this a 0, but I recommend that once you change this to a 1 and everything below it a 0, go to the next diagonal, make sure you have a 1 there, and then use that to make everything above it and below it 0. So I have a 6. So how can I make a 6 become a 1? If you're trying to make something a 1, then you can multiply by its reciprocal. So the reciprocal of 6 is 1/6. So I'm going to multiply 1/6 times row 2, and whatever answer I get, I'm going to put it back in row 2. So my first row is not going to change, only my second row. So we're going to have 1/6 times 0, 1/6 times 6, and 1/6 times -2. Okay, so my first row, I just wrote it the same way. 1/6 times 0 is 0. 1/6 times 6 is 1. And 1/6 times -2 is -1/3. And so now in my goal, I have my 1 Everything below it is 0. I have a 1 in this diagonal. Now I need this -1 to be a 0. Okay, so whenever you want to make something a 0, then you need to add by its opposite. So here you have a -1 and a +1. If we add the two rows together, row 2 plus row 1, put our answer back in row 1, then we get our 0. So 0 plus 1 is 1. 1 plus -1 is 0. And -1/3 plus 5 is 14/3. And then the second row just stayed the same. So why is it important to end up with this? Well, now if we rewrite this, then we see that x is equal to 14/3. And then this should say y is equal to -1/3. Okay, so let me go ahead and just fix that. X is equal to 14/3 and y is equal to -1/3. We're going to try another one. And so here we have just a matrix and we want to solve the system. And so the first thing is you want to make sure that you have a 1 in the diagonal to begin with. We want a 1 here. But when we look at our problem, we have a -3. Okay, so below it, I have a 6. So it wouldn't help me to switch rows. Okay, so what I can do is I'm going to multiply this -3 by -1/3, and it's going to become 1. So -1/3 times -3 will become 1. And I'm going to do that to the whole row. And I'm going to put my answer back in the same row. So let's go ahead and do that. So 1/3 times -3 is 1. -1/3 times 4 is -4/3. -1/3 times 22 is -22/3. I didn't do anything to the second row, so I just write it as is. Okay, so now that we have the 1, we need everything below it to be a 0. So I need to change this 6 to be a 0. Remember, if you want to make something a 0, we add it with the opposite. And so I need to multiply this 1 by a -6 so that I get -6 plus 6 would give me that 0. So that's going to look like this. So that's going to look like this. -6 times the first row. I'm going to add it to the second row. And whatever answer I get, I'm going to put in the second row. So that's what these symbols mean. I didn't do anything with the first row, so I'm just going to write it as it is. And now I can go ahead and do the work. So -6 times 1, -6 plus 6 gives me 0. -6 times -4/3, that's going to be 8, right? And then -4 gives me 4. And then the last one here, -6 times -22/3, that's going to give me 44, plus -28 will give us 16. So now we have our 1, we have our 0. So the last step here is, or not the last step, but the next step is I need to have a 1 where this 4 is located. So in order to make this a 1, I'm going to multiply this 4 by its reciprocal, which is 1/4, and then that's going to change it to a 1. So I'm going to have 1/4 times the row 2, and whatever answer I get, I'm going to place in row 2. So let's see how that would look. I'm not doing anything to the first row, so I just write it as it is. And now I'm going to multiply 1/4 times 0. It's going to be 0. 1/4 times 4, and 1/4 times 16. So 1/4 times 0 is 0. 1/4 times 4 is 1. And 1/4 times 16 is 4. And now I have the 1 here. So now I need to make the number on top become a 0. So in order to do that, we multiply by the opposite, which would be 4/3, so that they can cancel out. So I'm going to multiply 4/3 to the row 2, add it to row 1, and then put our answer in row 1. We're not doing anything to row 2, so I'm just going to write it out, and then we can do the work. So 4/3 times 0 is 0, plus 1 is 1. 4/3 times 1 is 4/3, plus negative 4/3 is going to be 0. Okay, so 4/3 times 1 is 4/3, minus 4/3 is 0. And then the last one, 4/3 times 4 is 16/3. And then minus 22/3 gives us negative 6/3, which is negative 2. And so now we can get our answer. X is equal to negative 2, and Y is equal to 4. Okay, so X is negative 2, and Y is 4. So that was solving systems of equation using matrices. A little bit of 8.2. Let me see what time it is. 10 minutes. Okay. So now we're going to look at a little bit at operations. And so two matrices are equal if they have the same dimensions and corresponding entries. And then they can be added if they have the same dimensions, and we add the corresponding entries together. Scalar multiplication just means that we're multiplying a real number to the matrix. And then two matrices can be subtracted if they have the same dimensions. And so we'll look at a couple of examples here. So here we're multiplying 3 times A. 3 is what we call the scalar. And so what that means is you're going to multiply every single element in the matrix A by 3. Okay, so that's going to be 3 times 2, 3 times 2, 3 times 4, 3 times negative 3, 3 times 0, and so on. Okay, so here you can see where we're multiplying by 3 to every single entry. And so we end up with 6, 6, 12, negative 9, 0, negative 6, 3, and 6. Now the second one says to multiply the matrix B by a negative. So negative B is the same as negative 1 times this matrix. So negative 1 is your scalar. So every single element will be multiplied by negative 1. So negative 1 times 2 is negative 2. Negative 1 times 0 is 0, 0, negative 1, positive 4, negative 3, 1, negative 3, and negative 2. And then the last one, we want to do the operation 3A minus B. So 3A, we saw that it was 6, 6, 12, negative 9, 0, negative 3, 6, 3, 6. And then minus B was negative 2, 0, 0, negative 1, 4, negative 3, and so on. So to add, you want to check to make sure they have the same order. So this is 3 by 3. Just if somebody says, do they have the same order? They're just saying, what is the dimension or what is the size? So this one is a 3 by 3 and this is 3 by 3. That means we can add them together. And so to add them, we're going to have 6 plus negative 2 is 4. 6 plus 0 is 6. 12 plus 0 is 12. Negative 9 plus negative 1, negative 10. 0 plus 4 is 4. Negative 3 and negative 3 is negative 6. 6 plus 1 is 7. 3 plus negative 3 is 0. And 6 plus negative 2 is 4. Okay, so now when you're doing your homework, WebAssign, sometimes you need to be able to make your matrix either smaller or bigger. And so you're going to see these green arrows. If you click on them, you can add rows, or you can click to add columns. Okay, so make sure that you look for those green arrows so that you can adjust it as needed. So it says, if possible, find a plus b, a minus b, 3a, and 3a minus 2b. So one, you want to ask yourself, for a plus b, do they have the same order? So here, the order for A is 2 by 3. The order for B is 2 by 2. Since they don't have the same order, that means that we cannot multiply them together. I'm sorry, that means that we cannot add them together. So our answer would be impossible. Okay, so for this one, solve for X and Y. So here they tell us that this matrix is equal to this one. And so if they're equal, that means that they have the same corresponding elements. So for example, -4 is here and here, 6 and 6. So that means that X has to be -3 and Y is going to be 21. If we look at the next one here, we have two equal matrices. So 18 is 18, 5 is 5, and then we have X and 2X plus 5, 2 and 2, and so on. So since I know that these are equal to each other, then we can go ahead and solve for our variables. So X is equal to 2X plus 5, and then I have that 5Y minus 4 is equal to 16. So now I can just solve these equations. So I subtract 2X, I get -X equals 5. So X is equal to -5. And then the other one is Y is equal to 4. Okay. Solve for X in the equation. So here we want to solve for X. So you're going to multiply 2 times A and 2 times B and then add them together. So I have my matrices. And then it's 2 times -3 is -6. 2 times 2 is 4. 2 times 3 is 6. 2 times -2 is -4. 2 times 0 is 0. 2 times 4 is 8. And then on this side we have 6, 4, -10, 10, 0, and 6. Now the order is 2 by 3. So I can multiply. I'm sorry, I can add. So -6 plus 6 is 0. 4 plus 4 is 8. 6 plus -10 is -4. -4 plus 10 is 6. 0 and 8 plus 6 is 14. And then we have another example here. It says solve for X. So the first thing that I recommend is just solve for X in the equation. Okay, so I'm going to bring 4B to the left side, and I'm going to take 2X to the right side. Divide by 2. So -2 divided by 2 is -A, and -4 divided by 2 is -2B. And so now we can use the matrices. So we have -A, so that's -1 times A, plus -2 times B. So we're going to multiply everything in here by -1 and everything in here by -2. So we end up with 2, -1, -1, -1, or +1, 0, and -4. And then on this side, we end up with 0, -4, +4, -6, 0, and -6. So they have the same order, so I can add 2 plus 0, -1 plus -4. So 2 plus 0 is 2, -1 plus -4 is -5, -1 plus 4 is 3, and 1 plus -6 is 5, 0 plus 0 is 0, -4 plus -6 is -10. Okay, so I think for next week, what we'll do is we'll continue with matrices, and what we're going to be looking at is multiplying matrices together. And then after multiplication of matrices, then we're going to get into finding, let's see. So the last slides here, they're all multiplying matrices, and those take a little bit of time. So I'm going to save it for next week, and then we'll just combine it with whatever's scheduled for next week as well. If you want to download the PowerPoint, you can right here where my mouse is. If you look to the top, you should see a box with an arrow pointing down. You can click on that, and it will let you download the PowerPoint. And I'll pass it over to our wonderful staff.
Next week, we will have for Math 1314 inverses and determinant of matrices, and for Math 1324 basic concepts of probability, permutations, and combinations. Thank you so much to Professor Ivechuka for presenting today. Thank you to the audience for coming and being a wonderful audience, and we hope to see you again soon. Thanks.